So let's go ahead and implement a simple video game, and along the way this is going to teach us something about creating custom views and about animation and lots of other fun stuff. So I'm going to start by creating a new Android Studio project, and I'm going to call it Catch the Clown. So this is a video game that we build as the first video game in CS133G. But we use GameMaker to do it there, which is not nearly as much fun as using an Android app. So we're going to do the Android app version this time. And I'm going to put this in my Android projects folder. And we'll use API level 10. And I'll start with a blank activity, main activity. And just as a personal preference, I'm going to have my game grab the whole screen. So I don't want an action bar. I'm just gonna make it be a regular activity. I have to wait for Android Studio to catch up. There we go. So Alt plus Enter to get activity. And then let me start with creating my new view. So I'm going to create a new Java class, and I'm going to call it my game view. And I want this to extend a class called SurfaceView. And SurfaceView is just like a regular view, like a text view or an image list or a grid view or whatever. But it gives me a blank canvas that I can draw on. And actually I misspelled that, should be extends SurfaceView, and Alt plus Enter to resolve SurfaceView. And then it's complaining I don't have a default constructor, so Alt plus Enter again, and create constructor matching super. And then I can choose from a couple of different styles. So I can create one that just takes a context, and that's the activity context, or one that takes a context and an attribute set. So this attribute set, when you're editing the XML file in here and you put attributes in your XML tags, those get passed in as an attribute set when you construct the view object. So in your constructor you can check to see whether particular attributes are set in your XML file, and you can do different things depending on those values. And some style stuff, and I'm going to pick this one. I don't have any plans to put any attributes in my XML, but let's go ahead and choose that anyhow. And so all the default one does is it calls the super constructor and passes in the things that it got. So what I'm going to want to do though is I want to keep track of my context, because I'm going to need to pass that to the thing that actually runs the game. So I'm going to create a private context, context, and then here I'm going to set context equal to context. Oh, actually I have to put it here, I think. There, okay, so now it's happy. Now, the first thing I want to do is surface views have surface holders. So the view is the thing that shows on the screen. The holder is the thing that actually controls that view. And the holder is the thing that gives you the canvas. And so you need to actually wait until the holder has been created before you can do anything with the holder. So I'm going to create a private surface holder called mHolder, and I'm going to set that to getHolder. So this is getting the holder for this surface view and storing it, but then I need to get called back from the operating system when the holder is ready to start being drawn on. And so the way you do that is you implement an interface on SurfaceHolder called Callback. And if I implement those methods, I get when the surface is created, when it's changed because it's resized or rotated, and when it's destroyed. So I'll implement all of those methods. And then I need to notify the API that I want to get this view called back when those events occur. The way you do that is you set the mHolder.Callback, and then you pass it in this. So now this object is going to get notified when any of these events occur, and then we can start doing our thing. So in my surface created, what I want to do is start up a loop that's going to actually update my game logic. So I'm going to have stuff moving around on the screen, and I'll be playing sound effects and have various things going on. And I'm going to have that all in a main game loop, which is a runnable. And then that way I have a clean separation between the view implementation and the game implementation. So let's go ahead and start that. I'm going to create a new Java class called Catch the Clown. And this is going to implement runnable. And then I'm going to implement the run method. And so this is going to be the main loop that gets called when my game starts up. So here I want to create a new thread. And let's go ahead and put that in private thread game thread. Should be m game thread. So we'll set m game thread equal to new thread, new, and then instead of runnable, I'm going to pass it catch the clown. Since catch the clown implements runnable, everything should work correctly. So if I've done everything correctly, then I should have a view that will not do anything interesting, but I want to display it when my app starts up. So let me go to my layout, and this game view, I can put it inside of a layout just like I would put any other view inside of a layout. It can be in a linear layout or a relative layout or a frame layout. It could be a fragment. It can do all that stuff. But what I want to do here, since I want my game to have the whole screen, is I'm just going to have a top level game view that's going to fill the screen. And the way I specify that this view is attached to this class is by putting the package name and class name. So com.example.mark.catchtheclown.gameView is this guy right here. Oops. And then that is the type of the view. Now, this is going to be a singleton tag. There's not going to be anything inside of it. So now I have a game view, and I need the width and height. I don't want any padding because I want to fill the screen. And I'll leave that tools context. So here's where I would add any additional attributes that would be passed into my game view in this adders. But I think that's enough for now. Let me just do one thing. So when this thing runs, I'm going to just change the color of the view so that you can see that it's actually doing something. And the way you draw to the view is first you have to get the holder, and then you have to get a canvas from the holder. Then you draw to the canvas, and then you basically tell the holder that you're done drawing. So first thing I need is the holder, but I don't have the holder here, so I can't get the canvas. So let's fix that. I'm going to define a surface holder, mHolder, make that private. And then I'm going to create a constructor for my catch the clown class. So public catch the clown, and this is going to take a surface holder, and it's going to set mHolder equal to holder. So then when I build the build the catch the clown object, I'm going to pass it in the value of holder. I could also use mHolder, should be the same thing. And then I'm also going to want to have this thing access some resources. So I'm going to have some drawables and some sounds. So drawable things that I'm going to draw in my view and sounds that I'm going to play for sound effects. And so I need the context in order to get those resources. So in addition to the surface holder, I'm also going to pass in a context. And then I'm going to have a private variable for that. And I'm going to set mContext equal to my context. And then I have to pass that in when I create my catch the clown object as well. So now I have the context and the holder. And my run method, it's going to look like this. So I want a canvas. Lock canvas is going to return a canvas, and then canvas dot, let's see, draw color, and let's just use color dot red for now. So it should paint the screen red. Alt plus enter, and then when I'm done drawing, I call mHolder dot unlock canvas in post and pass it in the canvas I drew to. And so all this should do is paint my view red. Let's go ahead and try it. Okay, try it on the Jenny motion. Okay, so oh, not quite. Let's see what. Maybe it's still going. So let's see if I got any errors here. Oh, I think I created the thread, but I didn't actually call it. I never actually ran my thread, maybe. Let's see what happened. Yep. So I created mThread, but I never actually started it. So mGameThread.start. Ooh, there we go. So now it's drawing red to the screen, and I have the entire drawable area to myself. Okay, so now that that's working, let's go ahead and draw a picture. So I've created a resource folder. Whoops, catch the clown resources, and this is in the lesson 8 content area. And so there's two drawables. There's one for a picture of the clown, and there's a background image that we can tile. And then there's some sound resources. So there's background music that will loop and play in the background. There's a sound that you get when you click on the clown, and a sound that you get when the clown bounces off the wall. So I'm going to start by copying these images, and I'm going to put them in my drawable folder. And I want them to go into the main drawable. And let's see how we actually draw those to the screen. So I'm going to just add a few lines of code here to my run method. So after I draw the background, actually let me put this at the top. So I'm going to create a bitmap clown, and I'm going to use the bitmap factory to build a bitmap for me, and I'm going to give it decode resources, and here I need to give it the resources associated with my context. So mcontext.getResources, and then r.drawable.clown, so the thing I just pasted in. So this is going to load my clown PNG, and it's going to convert it into a bitmap. And then to draw the bitmap on the screen, I say canvas.draw bitmap, give it the bitmap I want to draw, and then there's a couple of different versions of this. You can give it a drawing matrix, you can give it a source rectangle and a destination rectangle, and a paint. You can do the same thing except you specify coordinates in floats. You can specify upper left and upper left corner of the bitmap, and then it draws it at full size. So the easiest one to do is just say 100, 100 here, and then I have to give it a paint. So let me go ahead and create a paint as well. And I'm just going to use the default values for this. And now when I run it, it should paint the screen red and then draw my clown at 100, 100. Lovely. Okay, so there's my clown, there's the background. Okay, drawing the background is a little more complicated because we not only need to load the background bitmap, but then we want to tile it over the entire width and height of our background. So let's go ahead and start with that. So another bitmap background is equal to bitmapFactory.decode resources, decode resource, and context.getResources r.drawable.background. So there's our background. Switch this down a little bit. And then we need to tile it. So I'm going to create a bitmap drawable. And that's going to be equal to a new bitmap drawable. And we want to give it the context resources and also give it the background bitmap. So now we need to tell the drawable that we want to tile it. And in order to do that, we need to know the bounds, how big the actual view is. And we don't really have that information available here. So what I'm going to do is, if you look in the game view, you'll see that the width can actually change, width and height can actually change. So right here we have a width and height, but then right here we can have a width and height. And so we need to have a way of having the view tell our game that the width and height have changed. So what I'm going to do is implement a method here. First I'm going to track the width and height, and then I'm going to implement a public void set bounds, and then set mWidth equal to width, and mHeight, mHeight equal to height. And then in my game view here, I'm going to mGameThread.set. Oh, not actually the thread. I actually want to do this on the clown object. So let's do private catch the clown mGame, and we'll set mGame to this. And then pass in mGame here, and then call mGame.setBounds, get width and get height. So that's the width and height of this game view. And then if the width and height change, I'll call mGame.setBounds width and height here as well. So now I know the width and the height of the view. Oh. So for some reason it's complaining. Oh, that's right to me. Okay, well I don't know what Android Studio is complaining about because theirs gone. So I think it was confused about which get bounds I was changing. So now I have width and height. Let's go ahead and try to set our tile. Tile background set bounds. So 0, 0 is upper left corner, and then mWidth and mHeight are the side and bottom. And then I have to set the tile mode. So tile mode X, Y, and then tile mode repeat, and tile mode repeat. And then, so instead of drawing red here to fill the background, this one's a little different because instead of telling the canvas to draw the bitmap drawable, I tell the bitmap drawable to draw itself on the canvas. It's a little odd, but that's the way it works. So draw, and then I pass in canvas, and that should draw my background. So now I'm drawing the background and the clown on top of it. Ooh, there we go. So I have my tiled background with the clown floating on top. So now let's start animating this. And the right way to do this is to have a clown object that responds to various events and things like that. But this is a really simple game, and I want to keep this tutorial pretty simple too, so I'm not going to bother with any of that. What I need to know for the clown is its X position, its Y position, and then how fast it's moving in both X and Y directions. And then each time through a loop, I'm going to update the X and Y position and then redraw my scene. So let me go ahead and add some variables here. And I'm going to put this in my Catch the Clown class. So private int mClownX and mClownY, and private int mClownDeltaX and mClownDeltaY. So how fast the clown is moving in X and how fast it's moving in Y and its position. And then instead of drawing the clown at 100, 100, I'm going to draw it at mClownX and mClownY. And then I'm going to put this whole thing in a loop, so I don't need to loop any of this. But then getting the canvas, drawing my scene, and unlocking the canvas, that's going to be inside of a loop. So while, and now I need a way of stopping the loop when I'm done drawing. So what I'm going to do is create another variable, boolean mStopped. So this is going to start out being false, and then when it's true, I know that I'm done with my game and I should exit. So we'll start by saying, setting mStopped as false. Spell that correctly, false. And then while not mStopped, I'm going to loop. Okay. And then first, I'm going to set mClownX plus equal mClownDX. So this is the same as mClownX equals mClownX plus mClownDX, just shorthand. And mClownY plus equal mClownDY. So once again, mClownY equals mClownY plus mClownDY. And I'm not going to do anything else for right now. So this is just going to run right off the screen. Oh, I haven't set dx or dy to anything. So, oh, and I'm getting a little error here when I exit. So sometimes this canvas is mholder.lockCanvas. Sometimes this returns null. So like if I destroy my view because I'm exiting my app, this will fail and return null for canvas. So before I do my drawing, I need to actually check and see whether I have a canvas. There we go. And if I don't, rather than just spinning through this as fast as I possibly can, if I don't have a canvas, I'm going to want to sleep for a while. So let's say 100 milliseconds, tenth of a second. That's from the try-catch. So let's try it now. I still haven't set my dy or dx to anything, so we'll go ahead and do that in a second. I just want to see if I get the error when I exit. There we go. It took a little while to update. And no error. Okay, so I fixed that. So now when we start our run method, let's go ahead and create a random number generator. And let's set the initial position of our clown to a random number, random integer in the range of m width. And we'll also set our clown y to a random number in the range of m height. And then we'll set our dx to 5 and our dy to 5 as well. And now if we run it, it should start the clown at a random position and then start moving it. I think my thread is a little too busy until this actually starts, so let me try. Oh, there it goes. Okay, so it started, it was just a little late. Try launching it. Okay, so you see the clown's moving, oh, and it goes off the screen. So I want to figure out when the clown is about to hit the screen, the edge, and then bounce off. And I also want to play a sound when that happens. But this thread is running I'm doing too much work on here when the canvas is showing. It's spinning as fast as it can through here, and so it doesn't really have time to update anything else, which is not very friendly. So what I'm going to do is, even if I'm drawing, I'm going to give it a little sleep here as well. It's long enough to let the operating system catch up. Now if I did 100, I'd only be able to do 10 frames a second, so let's do 30, and that's going to give me a cap of 33 frames per second. It's probably okay. See if that made a difference. Okay, that was much better. So it started up right away that time. Not very zippy, but it'll get faster. Okay, so now how do I figure out that the clown is bouncing into a wall? So inside of this loop, after I've updated the X position and Y position, here's how it works. Let me draw a little picture here. Get paint. And I'll make that a little bigger. So here's my screen area. And then when the clown is outside of the screen, it's going to look like that. So here's clown X and clown Y, and then here is the clown X plus the width of the clown, and the clown Y plus the height of the clown. So I'm going to need those two things here. And let me go ahead and go back and add those two things. So I can figure out, after I've loaded this clown, I can figure out the clown height and clown width. Okay, so now I know the width and the height. And what I want to do, if the clown is off the side, then this clown X is going to be less than 0. And in order to bounce it, I want it to bounce off the same amount. It's bigger. So if it was here, that means that I should have bounced when I got here, and it should have gone back this far. So basically, if X is less than 0, then I want to set the X to negative X. So this is like minus 5 here. If it's 5 past the edge, I want to set it to plus 5. So let's go ahead and do that. If m clown x is less than 0, then m clown x is equal to minus m clown x. And we also want to flip the direction the clown is moving, so it bounces off the wall. M clown dx is equal to minus m clown dx. And then the case for clown y less than 0 is exactly the same. So if m clown y is less than 0, m clown y is minus m clown y, and m clown dy is minus m clown dy. So now we should have bounces off of the top and the left. Let's go ahead and test them by making the clown move towards those directions. Nope. Okay, so it didn't quite work. Just went right off the screen. So let's take a look at why that happened. So, oh, did I put it in the loop? No, I didn't put that in the loop, so I need to put that in the loop. Alright, so here inside the loop, after I update the position, that's where I wanted to do that. Ooh, it bounced. And it bounced again. And it'll just go right off the screen here. Okay, so that's the first case. And then the second case is going to be this one where the clown is off of this edge. So if x plus width, so this is x plus width, is greater than the width of the screen, then I want to bounce back by this minus that, and then that minus that. So this is, let's write this down here. So the Whoops, that's too big. Let's see if I can get a little font here. Let's make this like 8 point. Okay, so so the upper right corner here is clown X plus clown width, call that clown W, and then the side of the screen is just M width, and this minus that, so clown X plus clown W minus W is how much, so that minus that, this space is how much I want to go this way. So this is width minus that amount. So width minus that amount. And then parentheses here too. So multiplying this minus sign through, that's minus and then plus. So that gives me this point right here, and then I want to subtract off one clown width because I just moved this corner to here. So minus clown W, let's multiply this through again, so that's minus and minus. And so what we end up with when all the smoke clears is 2 times W, whoops. Yeah, so we end up with 2 times W minus 2 times clown W. So 2 times W minus 2 times clown W, and then minus clown X. And I think that's correct. Well, let's see if it works. So we'll do the X case. Copy that as a comment. So if clown X plus clown width, whoops, is greater than width, then clown X is equal to 2 times, and I'm going to factor that 2 and that 2 out. So 2 times M width minus clown width. And then subtract off clown X. So let's see if that's correct. And if this is true, we also want to flip the clown velocity. And clown dx is minus m clown dx. So let's see if we get a bounce off of the other side. And if that works, then we can do the y version as well. It's a little slow. I should have made it 10. Okay, so when it hits this, it should bounce off. Okay, well, it's close enough for me. I'm sure we'll get more chance to test it. So let's go ahead and copy this code and change it for our y. clown white, and clown height. And I'm going to speed this loop up a little bit. So instead of sleeping for 30 seconds, let's try sleeping for 10 seconds and see whether we get bogged down or not. 10 milliseconds rather. Okay, so bounce. Bounce, bounce. Yeah, looks like it's working. Close enough for government work. Okay, so let's go ahead and add a sound effect. So I'm going to write a play sound helper function here. And it's going to take a sound resource ID. And I'm going to start the way that we've been playing sounds through the course. So media player is equal to media player.create, and then I'm going to pass it my context and the resource ID. And then player.start. But one thing we haven't been doing throughout the term that you really need to do is you need to listen for when the sound is done playing and then release the media player. And some of you might have noticed in previous labs that if you get too many sounds playing, they just stop playing at a certain point. And that's because you basically run out of media player objects. So there's a finite quantity of them, and they don't automatically get recycled or garbage collected unless you get rid of them. So the way you do that is you set an onCompletion listener, player.set onCompletion listener is new onCompletion listener, and this is the method that gets called back when the sound is done playing. So in here we're just going to say player.release. There we go. And this will free up our sound when we're done with it. And now we actually need some sounds to play, so I'm going to create a new resource directory, and this is going to be raw, no qualifiers. So now I have a raw folder, and I'm going to copy my bounce, click, and music to that raw folder. And then when the clown hits the wall, I want to play the bounce sound. So in here, and here, play sound r.raw.bounce. Okay, so it's playing sound. And it's a little pokey, but it's working. Okay, so now we have some sounds. Now I want to, oh, sound is still playing. The thread is actually still going. We haven't actually stopped the thread. So let me go back here to catch the clown. It resumes where it was. Now I have two of them, I think. Hit back button. Yeah, so that thread, it's just going along because I haven't stopped it yet. So let's go to our settings, apps, and catch the clown, force stop. Okay, so that's obviously not ideal. So let's go ahead and fix that. So we want to have our game view, when the surface is destroyed, have it tell the M game to stop. And then our game is going to implement public void stop, and it's just going to set mstop equal true. So when the surface view goes away, it tells the game to stop, and that sets mstop to true, and this loop drops out. Okay, and we'll exit. And I don't hear any sound, so I think it's really stopped. Okay, good. So now let's handle clicking on the clown. So in order to catch clicks, we need to implement a click listener. So make our game implement a click listener. It's actually all on touch listener. And then we have to implement some methods and on touch. So this is the thing that gets called when the user actually touches the screen. And so let's take a look at what we have. It returns an X, which is event.getX, and a Y, which is event.getY. And then these are these return floats. So let's turn them into ints. Okay. And what we want to do is compare these values. It's complaining about the return statement being missing. So return true. So what we want to do here is compare this x and y to the clown x and clown y to figure out if the user touched the clown. So if x is greater than m clown x and x is less than m clown x plus m clown width, that means the user has touched in the same column as the clown, between one side and the other side. And then if that's true, if y is greater than m clown y, and y is less than m clown y plus m clown height, then the user has typed both inside the x and inside the y. And just to make things a little easier, I'll use that, easier for the user. So if both of these things have happened, then I want to do a couple of things. First, I want to start playing a bounce sound effect, or a click sound effect rather. Play sound r.id.r.raw.click. And then I want to adjust my score. So let's have a private int score. And when the game starts, we'll set our score to 0. Actually, let's, I have a reason for doing this, but I want to go ahead and do this in the constructor. And score is equal to 0. And we'll give the user 10 points for clicking on the clown. And then what we're going to do is we're going to jump the clown to a new X and Y location. But before I do that, let's fix this. So this is going to set clown X to between 0 and, let's say this is 720, between 0 and 720. But the clown actually has some width itself. And so if the screen is 720 wide, the right-hand side of the clown is actually going to be at like 736 or something like that. If it's 16 wide, it'll be 736. So we actually want to pick a number between m height, or between 0 and m width minus m clown width, and between m0 and m height minus m clown height. So that way the right edge and the bottom edge will still be inside of our drawable area. And then I'm just going to copy this code down here and paste it in here as well. Now I don't have access to rand here, so I have to move rand, my random number generator, outside of the runnable. And I'm going to have to do a little refactoring here. So let's rename that random, and we'll make it private. And then I'm going to put this line inside of my constructor. Okay, so now I can access the random number generator from both places. So not quite working. Okay, so let's see whether we're getting our callback. Oh, I think we need to tell it that we want our callbacks. So not just implement the onTouch listener, but tell it we want callbacks. So let's try. All right, well, let's get the view. Context and view. In there. And then when I create the thing, I will pass in this. And then here, view.set on touch listener, this. Okay, so let's see if this works. Ooh, okay, so it worked. And I also want the clown to get faster every time I click on it. So let's go ahead and bump up the dx and dy. So dx times equal, actually 1.2. So m clown dx and m clown dy times equal 1.2. And this isn't going to, well, it should work. Let's go ahead and see it. It'd be better if I was using floats here than ints, but I started at 5 and I'm going 1.2, so it should actually still increase. Oh, yeah, so it's definitely getting faster here. Okay, so now it's becoming unplayable. Yeah, okay, so it's going sufficiently fast that I can't possibly click on it anymore. So this is why this game is really so terrible, because it just gets harder and harder, and there's no real end. You just get so frustrated that you have to stop. And so I've about reached that point. But everything's working. So another thing I want to do is to go ahead and play some background music. And I'm going to do something similar to the play sound event, except I want this thing to loop, and then I want to stop it when the game goes away. So this time I'm going to create a private media player background music. Public void play background music. And background music is media player.create and context and r.id, actually r.raw music and background music.start. And to make it loop, you set and background music.set looping to true. And then as long as you've stored this media player inside of a property so that it doesn't get garbage collected, the music will continue playing until you stop it. And the way you stop it here is background music.stop and background music.release. So let's go ahead and start it in the constructor. Actually, I was supposed to play the ID here, so this should just be ID. Okay, and I think that's it, so let's go ahead and play it. Okay, so you hear the background music playing. Can't really say it adds to the enjoyment that much, but there it is. Okay, so last thing I want to do is display the score on the screen here. And there's a command for drawing text. So let's go ahead and start playing with that a little bit. So here in our loop where we're doing the drawing, let's draw it before we draw the clown, after we draw the background. So canvas dot draw, it's not, yeah, draw text. And then I want to turn the score into a string. And here's a quick and dirty way of doing that. And then I need to specify the X and Y position. So this is actually the X and Y position of the bottom left of the text. So if I drew this at 0, 0, it would actually draw the text itself above the screen. So I'm going to specify, let's say, X position of 20 and Y position of 40. And then I'll make the text 20 big. So I need a paint for this, so let's call this text paint. And then I have to create text paint up here. I only need to do that once. And right after I create my paint, I'm going to set the color. What's a good color? How about black? Black is always a good color. So 0. I could also do like color.black or blue, cyan. Actually, let's try dark gray. Is there dark green? Magenta. So many colors to choose from in so little time. Let's just go dark gray and leave it at that. And then text paint dot set text size, and let's make that 20. So it'll be offset 20 from the edge and 40 from the bottom, and then it'll take 20 up. So let's go ahead and see how that looks. Oh, too small. Yeah, it's actually showing the number, but yeah, 20 is way too small. It's really going to depend on the resolution of your screen. So what we really want to do is we want to make it some portion of the screen. So if our width, so let's get the minimum screen dimension. And then let's make that a tenth of the total. So 0.1 times dimension. So it'll take out about a tenth of the screen size. And then I need to make that float. So let's see how that looks. Okay, so that's better, but then I have to change the starting position. So let's go ahead and go here. And go int text size equal to that. And then I want to make this be an integer. I'll pass text size here. And then I'll start offset by 1 text size, and then down by 2 times text size. Okay, so that's not bad. So, only other thing to do is when we hit rotate, we want to maintain the score and the velocity of the clown. I don't care so much about the position, but score and velocity would be pretty good to maintain. So what I want to do is basically implement something that's going to save these values to a bundle. And this isn't a view, so it's not actually going to get the life cycle events called that are associated with the view, and it doesn't have an on-save instance state to override or anything like that. But I can create my own. So let's go ahead and define public void on-save instance state, and this is going to take a bundle saved instance state, and I'm going to treat this just like a regular bundle, because it will be a regular bundle. So I need some tags. So let's do a dx tag. and we'll do a dy tag and a score tag. And I think these are all ints, yeah. Score, dx, and dy, all ints. So saved instance state dot put int dx tag m clown dx. dy tag m clown dy. And score tag is mscore. So that saves it. And then public void unrestore bundle saved instance state. So here we want to set mscore equal to save instance state dot get int score tag. And let's actually check and make sure that we actually have a saved instance state first. And mclown dx is going to be save instance state dot get int dx tag, and dy save instance state get int dy tag. Okay. And then we need to make sure that we initialize dx in the right place. So this would overwrite that. So let me get that out of there. And instead, if there is no saved instance state, mscore is 0, mclown dx is -5, and mclown dy is -5. So I think that's fine. And then in our game view, so my game view has to tell my catch the clown object to save its state. And does this have an unsaved instance state? I'm not sure. Let's see. I'll override public void unsaved instance state bundle saved instance state. Nope, it doesn't have one. So we're going to have to pass the bundle in from the main activity in its unsaved instance state. But here we'll call mGame save unsaved instance state, and we'll pass in saved instance state. And then we'll do the same thing with onRestore. Okay, and then in our main activity, here we'll override on public void onRestore instance state. And now we'll call super.onRestore. I remembered that time. And then we'll call our view. So where's our game view? We have to get our game view. So game view view equals game view. So it's just like any other view. r.id. Did I put an ID on that? Let's see. Nope. Let's put an ID on it. Just like any other view. The fact that it's a custom view and we implemented the draw method, Android Studio doesn't care. So view.onRestoreInstanceState, and we'll pass it that. And then we'll also do the thing for onSaveInstanceState. So when the user triggers one of these things, the main activity gets called. It calls the view, and the view calls the actual game, which adds its information to the bundle, and everybody's happy. So on save instance state, and on save instance state. Okay, so if everything's gone right, then it should save our state. Oh, not quite, not quite. So let's go ahead and put a breakpoint right here and run it the debugger. Oh, onRestore actually only gets called if the thing's getting restored. So I think we do want to put it in the creation event here as well. So we'll leave that there in case it does get called with null. And we'll also put it here in the constructor. Okay, so 30, 40. Okay, that's enough. So let me go ahead and rotate the screen. Score's 100. Pawn's moving pretty quickly. Oh, so we got an error. Game view doesn't exist yet. Okay. So this actually gets called before the game is created. So let's create the game earlier in the process, but then we don't actually have to start the thread until the surface is created. So as soon as we construct the game view, we'll also construct our game object, and then onRestore should do the right thing. Oh, but we need a holder, so let's do mHolder. I should really be changing the dx and dy here too. But okay, so rotate. Ooh, save the score, save the speed. Still not a great game, but it actually works okay. Alright, so rotate again. How exciting. Okay. Okay, so just two more things. First, in our touch handler, oh, actually catch the clone. Okay, so first in our touch handler, we're actually responding to both touches and touch moves, and we probably only want to make it look like a click. So basically, if you hold down the touch, hold down the mouse button and drag over the clown, that counts. But we probably only want to actually touch on the clown. So associated with this motion event is an action. So let's get the action. I think it's just an int. And then there are a bunch of different actions you can check. But I think what we want is action equal. Yeah, so these are all the different actions you can look for. Quite a few of them. But we're going to look for action down here. So when the user actually clicks on the clown, that's when we want to check to see if they've clicked on. Okay, so I'm holding down the button and dragging over. Now nothing happens. Before it would have worked, but here I click on the clown and it works. Okay, so I'm responding to the right action. And then the other thing I want to do is I want to scale this clown to fit part of the screen. So the same way I scaled the score based on the screen size, I'm going to scale the clown based on the screen size as well. And so all I need to change is here in my run method. So I'm going to basically do the same thing I did with this text size, except I'm going to create a clown size. And then let's make that just be a little bit bigger than the text was. So 0.15 f times dimension. And then the width is actually going to be my clown size, and same with the height. And then all the rest of the logic is based on clown width and clown height already, so that should just work. And then when I draw the clown over here, I need to use a version that takes rects. So let's define two rects. So I need a rectangle for my clown bounds, and let's initialize that. And a rect for my screen bounds. So this is going to be the source rectangle, and this is going to be the destination rectangle on the screen where I draw my clown. And then for the clown bounds, those are always going to be the same. It's just going to be clown bounds. So let's set 0, 0, and then clown dot get width and clown dot get height. And then my screen bounds I'm going to set dynamically. So we'll do that inside the loop. So screen bounds set, and then I want the clown X and mClown X rather, mClown X and clown Y, and then mClown X plus mClown width, and mClown Y plus mClown height. So this version takes clown bounds rect and screen bounds rect, and that should be everything. So this should draw me a bigger clown and should adjust the size of the clown based on the resolution and size of the screen, so that it always takes up roughly 15% of the total screen size. Okay, and now the clown is taking up about 15% of the screen width, which is correct. And rotate it. And okay, so this is getting frustrating. I'm going to call this a day. So our app works pretty well, and hope you've had fun, and I look forward to seeing your labs.